Hey, what's up guys, my name is Eternal. Welcome back to my game engine series. Second episode this week. Getting serious. So last time we talked about circle rendering. I'll have that video linked up there, and I thought that I would kind of continue on this trend of like filling in all of the features that our 2D renderer is missing. And today specifically we're going to be talking about lines. So if we take a look quickly at what we kind of left off with last time, we basically added the ability to render these circles. They can be filled in, they can be not filled in. They can have like this cool kind of fade look as well, and they also exist within our actual runtime. So if I hit play, you can see that we render these circles. Now, with lines and what we're going to talk about today, the primary reason that we're going to be adding these is for debug rendering. So as an example, we have these kind of like entities in our game that use box colliders, but there's no way to actually see what the box collider looks like. And I talked a lot about like, visualizing physics colliders in that last episode, so I'm not going to repeat myself here. Check out that video if you want. But basically, it's very important to be able to actually see what the physics system sees as opposed to what is being rendered, because the two can often not match. And that, again, might be intentional. It might be not intentional because there's simply a bug in our actual engine code, so it helps us during the development of our engine, but it also obviously helps us during the development of the game itself, because we can actually make sure that everything is kind of lining up as we would expect. So what I want to be able to do is draw like a rectangle around this kind of rectangle, right? I want to be able to draw these lines here that indicate the bounds of this box collider. Now, line rendering can be used for a lot more than just drawing like rectangles like that. For example, maybe where we have like, this is our player character and we want to do like a ray cast so that we can see like if he's touching the floor or something like that. It would be great to be able to just easily chuck a line up even through the actual like C# scripting code in the future to be able to actually visualize that kind of ray cast. So it's something that we want more than just for like, in kind of engine visualization, but also it might help developers using Hazel to make the game actually be able to visualize things. A lot of engines have something like this. And of course, rendering lines is quite useful to be able to do. Now, the thing that this is not, and the thing that like the way that we're going to implement it today is going to be like probably the simplest possible way. So it's not necessarily going to look amazing. Like I think if you want like potentially really thick or really nice soft lines or whatever in your game engine, you're probably going to want to go down the same route that we went down for our circles, which is basically like, I just want to draw a quad. Like you might want to draw like a thin quad, something like this. So this is like a quad, two triangles, and then you like have a shader within that actually draws your perfectly anti-aliased line that is as soft and smooth and whatever as you want. I would probably go down that route if specifically you are trying to make a game that revolves around lines and you need to render lines for your game, because obviously you would want them to look as good and as perfect as possible. Whereas for like debug graphics visualization, it doesn't matter what they look like, we just need to clearly see them. And that's why we're going to be actually rendering lines as a primitive type. So far, the way that we've been rendering things, if we go into our OpenGL Render API, you can see that we're drawing triangles. So what that means, that's our primitive type. What that means is that we are drawing basically every piece of geometry that we render at the moment is going to be a triangle, meaning that it needs to have 3 vertices, 1, 2, 3, right? And then from there, obviously, we can, fill in this and render a quad, because that's kind of the basis of our batch renderer. But the point being that, let me just make this a bit bigger. I don't know why I'm using Paint, by the way. Worst decision. But anyway, so we can kind of, have these indices here, 0, 1, 2, 3, 0, or whatever. Maybe I'll make it look like this. But we can basically draw these triangles because that's the basis for our quads. That's also the basis for our circles, because circles we render as a shader inside this kind of quad. But for lines, and what we can actually do is use a different primitive type. There's actually a bunch of primitive types in OpenGL we can use. So points, lines, line loop, line strip. We'll talk about those in a minute as well. Triangles, triangle strip, triangle fan. There's even like GL quad, which I think might be like, or quads might be like deprecated, I'm not sure. All of this is obviously up to the hardware, or rather the driver specifically, to be able to support. Triangles is the most common thing because for most geometry, because GPUs love to deal with triangles, and that's just how especially real-time graphics programming kind of works. Now, we do also have the option of lines. Now, again, I want to mention that this is something that is kind of hardware specific potentially, right? Like I remember back when I worked at EA on like the mobile engine that they had, You know, I'm pretty sure that we couldn't render lines natively. So we had to actually like render quads or render triangles, you know, and then render a quad and do all of that fancy stuff. So it was a little bit more complicated because the hardware, for some reason, OpenGLES or something, I don't know what version, I don't know what driver, but it didn't support line rendering. And so you have to be aware of like your target platform, your target architecture. Now, Hazel, whilst it might maybe support mobile hardware later, at the moment, we are focusing on just Windows and modern GPUs, right? And because of that, like I have no interest in trying to attempt to support stuff that maybe might work in the future. We'll cross that bridge when we get there is kind of the mentality we have here, because it's hard enough to build a game engine, not to mention something that supports absolutely everything, right? So we're going to just use lines for now. And the reason why I'm giving you this background is just so that you have an idea of like what is possible and just through my experience, right? But I think it should be fine on pretty much any modern hardware. It should, especially desktop GPUs, should easily be able to draw lines and we'll have no problem with it. Now, there are two more things, right? So what we can do, first of all, is using lines. If I want to just draw like something that is, you know, this is the line tool, right? If I want to draw something that is like, you know, outlining this rectangle, well, that's very easy to do. I can just basically draw 4 lines like this. Now, how would this look like? And how does that compare to our current kind of methodology of drawing this quad? Well, first of all, one thing you might notice is that when we draw quads, we actually draw elements. So this is an indexed draw call. OpenGL for some reason calls like index buffers like element buffers and indices elements. I don't know who and why made that decision, because it's very different from any other API where it's just called index, and I think that makes more sense, to be honest. But anyway, so draw elements, draw index, same thing. But the point is, what we do is we actually have an index buffer. And if we look at this index buffer that is inside Renderer 2D, then you can see that here it is, our quad index buffer. You can see it follows this kind of pattern of 0, 1, 2, 2, 3, 0, and then the offset increases by 4, so that the next time we do it, it's 4, 5, 6, 6, 7, 4. But basically the point is that we're creating this index buffer that lets us not duplicate vertices 2 and 1, right? So these 2 vertices are reused when we draw a quad. We draw 2 triangles like this, right? But then these 2 vertices, that's great, whatever, that's even worse. These 2 vertices are obviously the same, so we don't need to duplicate them. Now, if you have like, I don't know, if you have like a cube or something, you know, you can also kind of save some vertices potentially, or so you might think, but we have a different problem here, because with cubes usually, if we need normals, which very often we do need normals, you'll note that even though this single vertex might be shared by like 3 triangles or even more, right? If we have this situation, that's 1, 2, let's do this one. 1, 2, 3, 4, 5, 6 triangles are sharing the same position. However, they might have different normals, because this face is obviously facing that way, that face is facing this way, this face is facing this way. And so we can't really get away with not duplicating that vertex, because a vertex is more than just its position, right? It can also have other vertex data inside like the vertex attributes. And so that's a bit of a different story. Again, not that relevant here because this is Hazel 2D, but just something to be aware of. Now, for a quad though, that is entirely facing the camera, and again, we don't have normals either, obviously these 2, we can get away with not having 6 unique vertices for 3 triangles, because each triangle is 3 points. We can get away with only having 4, and then use something called an index buffer. I'm pretty sure I explained all of this in like the index buffers episode, but that was like probably years ago. Anyway, the point being, how does this tie in with lines if we want to draw this kind of red line outline thing? Well, with lines, our story is a little bit different, because a line only has 2 points. And because a line has 2 points like this, that means that we don't really, like if we were to use an index buffer, well, it would just be 0, 1. And then if it's 0, 1, then we don't really need an index buffer, because we can just use draw arrays instead of draw elements, and that will just work. And so that's what we're going to do today. Now, I was talking about all these other primitive types, and that's kind of important as well, because you can see we have lines, but then also line loop and line strip. So what's that all about? Well, line strip, keep opening Hazel. Line strip is basically, you know, pretend that we wanted to draw a bunch of lines in a row. So we had like this line, but then after that we wanted to draw this line and then this line, and they're all connected. Well, here again, you might be like, well, do I really need to duplicate these vertices, because if this is one line 0, 1, 2, then I need to again have a vertex here, but they join. And that's kind of what a line strip is supposed to avoid. So a line strip just lets you be like, okay, well, you know what? If you're just going to connect a bunch of lines together, let's not worry about duplicating vertices. Just do 0, 1, 2, and 3. So therefore, we can draw something like this, right, with just 4 total vertices. A line loop is very, very similar, except it joins back to the end automatically. So in that case, it would join like that. But, you know, why is it useful? Well, pretend that you are, in fact, drawing this rectangle, or you're just drawing an arbitrary polygon like this. Well, then you would probably want it to draw back here. And so what this means is that with a line strip, you would have to duplicate that first vertex. So you'd have to be like 0, 1, 2, 3, 4, and 5. But with a line loop, this last line automatically happens, and so we don't need that last vertex. So it's useful for this kind of stuff, and it can be efficient. We're going to throw all of that out the window. Why? Because it's just going to be simpler for us to just focus on lines at the moment, and it's definitely going to be fine for performance. Again, we're not trying to make something that can render a billion lines. We're probably not going to render that many lines in general, so it's going to be totally fine for us to just not do that. And so what this will be slightly less efficient, because it will just be 0, 1, 1, 2, 2, 3, and then 3, 4, I guess. Right, 0, 1, yeah, 0, 1, yeah, they'll all be separate lines, even though they are kind of joining and they're sharing this vertex. Because the idea is they might not be. And again, we are specifically drawing lines, just one line. That's what's going to be drawn, right? And then if you want to make a rectangle out of it, well, you have to draw 4 lines. And so you will get some duplication, but that's kind of the route that we're going to go down. So how's this going to work? Well, again, we've established that we don't need an index buffer. So what that means is we can actually copy this, change this to something like, I'll just call it draw lines. And then we're going to pass in a vertex array, and this is not going to be an index count. It's just going to be a count. In fact, I'll call this vertex count. So our vertex count over here is going to be how many vertices we draw. Why do we need this? Because we'll bind the vertex array and then call GL draw arrays instead. This is like the more simple way to draw things. I'm pretty sure most OpenGL tutorials probably teach this before they teach draw elements, because draw elements requires an index buffer. This just requires a vertex buffer. That's it. So if we do draw arrays with that lines primitive type, then it has slightly different kind of parameters here. It's got the first kind of vertex. So this is like the vertex offset of what we're talking about. And then the count is going to be how many vertices we actually want to draw, which can be vertex count. Now I could set up like a, just like a primitive type enum class or something so that we can pass in anything into here. But the thing is, I'm going to keep this a little bit simple because first of all, I'm not a huge fan of this render API. I had kind of a different idea going forward, and I kind of regret the path that I went down. But also, like, the more I think about it, the more I'm realizing that we will probably switch to Vulkan sometime soon, just because I don't like OpenGL is becoming less relevant to most people, and Vulkan's going to give us like more platform support, and it's just going to be a better time in general, because the more I use Vulkan, the more I like it compared to OpenGL. But what we will still do is, this is like the official roadmap, hazelengine.com/roadmap. We will still kind of get through this. We're not going to pause and rewrite the engine in Vulkan. We're kind of doing the minimum kind of vertical slice here. We're doing our first kind of minimum viable product, one vertical slice, I guess, of everything that we're doing here. We want to make sure that we can actually make a game first, and those tools are available and they're more or less implemented, and then we will maybe loop back and talk about Vulkan and all of that stuff. So because of that, I don't want to like spend a lot of time on this OpenGL kind of render API and make it perfect, because we are probably going to rewrite it with something a little bit more relevant for today's time. Right. So that being said, though, this is basically all we need to do. So let's go back out and create this and fill it out in the rest of our render API. So this becomes just a virtual void draw lines override. Let's copy that, go back to renderer API and add that in. So virtual void draw lines equals 0. And then I think we also have render command. And then in render command, we just need to call that. So sRender API draw lines. And then I'll change this to vertex count. This should probably be called index count, by the way, this one up here. But yeah, that's basically it. So I don't know why this is, so this definitely shouldn't be 0. It's 0 here because if it's 0, then it will actually use the vertex array's index buffers count. Otherwise it will override it. But we don't have anything like that, so 0 is definitely not permissible. It's not going to draw anything. Okay, well, great. That's basically all we need. So now our batch renderer needs to be able to create these lines. And the thing is, at the end of the day, like, remember, a line, like, lines are very easy to draw. Lines are just one point, another point, that's it. So if we look at what we currently have, like, we obviously don't want to put them into the quad vertex buffer. We'll need to have another kind of pass for this, just like we had with circle vertex. So we can duplicate, let's duplicate quad vertex, and we'll call this line vertex. And line vertex is going to basically not have, it's going to basically only have these two, text core, text index, tiling factor, no. We can still have an anti-ID potentially. The thing is, because this isn't going to be a game side thing though, it's not really going to like implement, it's not really going to be implemented in like the entity component system like the circle renderer was. So this is something that is entirely going to just exist in the C++ code for the renderer, and then later can probably be called from like the scripting language, right? As well as like from the editor when we decide to visualize our physics colliders as an example. So this stuff is definitely not like, I'm not sure if we should have an entity ID, but then again, I am picturing that people are probably going to want to maybe draw lines for inside their game. So maybe we'll keep it for now, but I think that in the future, we might revisit this and make it like a slightly higher quality line rendering thing. Even though I think OpenGL has like some kind of GL smooth lines enable that you can do to like get some anti-aliasing on the actual lines themselves. So that might be nice, but we'll see. Okay, so line vertex. So what do? Well, again, I'm going to just reuse this stuff for now. We'll do a pass and clean everything up eventually, but I'll copy like all this circle stuff. And then again, we're just going to basically find a replace with line. So we're going to have a line vertex array, a line vertex buffer, and a line shader. And then if we grab this, we're also going to have the same thing. So a line, except we'll call this just a line vertex count instead of index count. And then it's going to be a line vertex buffer base and line vertex buffer pointer, which will be of type line vertex. Coming down into circles, we're going to copy this. We're going to rename it to lines. And then, yeah, again, this is just going to be like a find replace. We're going to replace circle with line. I'll just match case as well. And there we go. Okay, so let's trim some of this fat. So that's gone. And we just have a position, a color, and an entity ID for our buffer layout, because that's obviously the layout of this. We're not going to use this index buffer. And yeah, line vertex max vertices. Again, like, do we need like that many? This is going to give us a lot of lines, right? Because this is times 4 as well. This is going to give us like 40,000 lines, because we have 20,000 times 4, which is 80,000, divided by 2 is 40,000. So we don't need 40,000 lines. Again, we will revisit this stuff probably and have some kind of resizing buffer or flushing more frequently, something like that. But I don't want to kind of spend this episode talking about that at the moment. So let's come down here to the shader, and we'll have a line shader, which we'll make in a minute. And then let's just set up the rest of this now, I think. So what do we need to do? Well, in start batch, we just need to basically reset everything just like we do here. So I can copy this stuff and then just make sure that we are resetting this. So line vertex count, line vertex buffer pointer, and then line vertex buffer base as well. So we reset this stuff in start batch. In flush, we will basically see if we have any lines to flush. So we'll check the line vertex count to make sure it's not 0. And then again, you know, circle line was already written there. We'll just replace that. Now we don't need this draw index. This becomes draw lines instead, right? So render command draw lines, and then we have the line vertex count, and that should be good. Now, why are you upset? Apparently we have no render command. Did I add that? Oh, I didn't actually call it draw lines. Awkward. So there we go, draw lines. We'll talk about line thickness as well in a minute, but let's just get the lines rendering in the first place. That looks good, I think. So now let's talk about the actual like draw command. So we have draw circles, or draw circle. Let's make another one called draw line. This is just going to take in 2 points. So we're going to have a start point and an end point. So we can have P0 and then P1. we're just going to draw a line from like one point to another point in 3D space. 2D line, right? But it's in 3D space, just like the rest of our engine, basically. So color, do we need a thickness? Now, we're not going to have a line thickness per line because we can't really do that. We're just going to use something called gel line width to set the line in a minute. Fade obviously doesn't exist. So we just have like the points, then the color, and the entity ID, which is probably going to do nothing at the moment because it can't really do anything. Because we are not drawing them from entities, right? So as data, line, vertex, buffer, pointer, and then we'll start with the position. So this is easy. This is just going to be P0. Now the transformation, so this is already expected to be in world space, this position, and the transformation into like view space and all that stuff will happen like within like the actual shader inside our vertex shader, as I guess you would expect. So color is color. And then we'll set the entity ID to -1, which is what's happening at the moment over here. Now let's increment this pointer. And I'm going to duplicate this entire thing, except we're going to use P1. That's it. And then finally, obviously, we should set the line vertex count. Try again. to plus equals 2. And that's basically it. Now for a rectangle, we're just going to draw 4 of these. So we'll make the draw rect function in a minute, but this is basically like it. And I think the last thing that remains is to actually draw our shader. Not draw our shader, to actually write our shader. So we're binding the shader here, and then we're drawing this, which should bind like the vertex array and all of that stuff, which it does. So yeah, we literally just have to write a shader now. So I'm just going to open this. We're going to duplicate. We can probably duplicate within Visual Studio. I don't know why I keep opening it in like Windows Explorer, but because I'm pretty sure I could just copy paste here. But if we open up render a 2D line, this is our circle shader. Probably should have copied the other shader because it's, yeah, let's go back to like quad and we'll just copy that. Although we do have all of that stuff we don't need. It'll be more like this one, just in the sense that it has these two. So let's get rid of this. This becomes location 2. I really should get that GLSL or the shader language like syntax highlighting, but whatever. So we don't have obviously text core tiling factor. That goes away. NTID will still keep. It's separated from the struct because it has to be flat. Is that it? I think that's it for the vertex shader. The fragment shader, again, I don't like that we should just fix this, I think, across the board. I don't like that these two are just called color 1 or like color and color 1 or color and color 2. They should be called output color and output entity ID like this. Let's actually quickly patch that up for our quad shader as well. Because, oh, it is patched up. What? Did I just patch that up? Oh no, I patched it up in the wrong place. So let's also do it in line, right? But back in the quad, I'll obviously make this work because we're setting color and color, output color and color 2, but instead we'll change that to be output color and output NTID like this. Okay, so back in line, let me just close the other shaders so I don't get distracted. Let's get rid of like basically all of this. So output, so the V entity ID, yep, is going to be our output entity ID. And then output color is simply going to be the input color. It's very simple. We don't need to do anything here. It's just going to be input.color. We'll get rid of the rest of this, get rid of this. This becomes location 1, no textures. And I think that looks pretty good. That's our line shader. Again, super simple, nothing really to it. Let's try and run this. So let's try and render this first of all. So back in scene, remember to do this between like begin scene and end scene. Otherwise you'll have to like set up the camera again, which is fine, but it won't work if you do it outside of that. So we'll do draw line. Let's just draw it from like 0. So we'll draw it from the origin of the world into maybe 5 meters in each axis. So we'll set the color to be like pink, magenta, and the entity ID will leave as -1. Okay, that's it. So if I've done everything correctly, which I don't know if I have, but we should see like a pink line, even without loading a scene, going out into the world. So it's compiling the shader, and there's our pink line, right? Super simple. Looks like it's about right, going to the right position and everything. Now, how do we make this guy a bit thicker? So the line thickness thing, is an OpenGL global. Again, OpenGL loves its globals. It loves like just setting state, and then that's kind of it. That's just the OpenGL way. It's a bit annoying, but that's how it works. So let's also add something here called set line thickness. I won't call it line width. I'll call it line thickness. I think that makes more sense. Maybe I should call it line width because that's like, let's call it line width just because that seems to be what they call it. I was gonna go my own way, but whatever. So we'll copy this. We'll pop it into render API as well. Set line width. I guess we should call it width. Equals 0. And render command needs it as well. Float width. Set line width. Width. And if we go back here to here, let's implement it. And it's just going to be a one-line OpenGL function, GL line width, and then width. So again, this sets it kind of globally. Like in other APIs, like in Vulkan, for example, this is something that you set like into your pipeline. So it would be a bit different in that sense. You can actually also have it set as dynamic state in your pipeline, meaning you can encode it into your render command buffer or into your command buffer, like before you render a particular draw call. But again, it is something that you do per draw call. So unless you write, you do the whole quad thing that I was talking about and you write your own shader to render the lines, in that case, you can do whatever thickness you want dynamically per line, and it would still be batched into one draw call. In this case, if you want different thicknesses, you're going to need different draw calls. But again, because we're using this for debug rendering, I think it's fine to just be like, you know what, arbitrary thickness of like 5, and that's across all lines. But again, if you're making a game, I can imagine that, yes, you would probably want different thickness lines. And this could be a problem. But again, I wouldn't render lines like this if you want to make a game revolving around the use of lines. So let's go ahead and actually like set the line width before. So we don't have this yet, but I'll just basically set it. We'll set it like this, pretty much every frame like that. Don't think it'll be that bad for performance, and that way we can easily just make the code a bit easier. So let's go ahead and make a float line width. I'll set it to 2 by default. That's not 20. I like a line width of 2. So s data line width, and then we'll obviously have to make some kind of, whoops, static void. We'll make float get line width, and also set line width. This will of course return s data dot line width, and this will set it to width. Okay, so now we should have a line width of 2, which we should be able to see. I mean, we can try set it to like a high number to make sure that works properly. But yeah, you can see that it's a bit thicker. And I don't know if there's like a limit. I mean, like I guess if we just add 20, I don't think there is a limit, but I might be wrong. Yeah, it looks like there might be a limit. I think there's a limit of 10 or something, because I don't think this will just keep going up. And that didn't really look like 20 to me. Yeah, so there is a limit, but again, for debug rendering, this is usually fine. What are we at, like 28 minutes? Okay, so we've got some time. This is like a shorter episode than usual, right? So let's go ahead and add in that draw rect. So this is going to kind of be like a little bit more akin to how we draw like everything else. So we kind of want to use a transform. We can definitely use a position and a size. I guess I should probably add that API as well, but I think that this is probably going to be something that you definitely want to be able to set a transform for. So we'll do position size, and then I'll also make a draw rect that takes in a transform, because that way we can give it the entity easily, and it will automatically like use the rotation, use the translation, the scale, all of that. I'm not going to make a draw rotated like rectangle, because again, you can just use the transform overload for that, which we don't have yet, but here it is, transform. So let's make it work with both of these. Just create that implementation with Visual Assist's help. Okay, so Okay, so how's this gonna look? Well, first of all, I mean, for this case, it's really simple. We're just gonna call draw line 4 times, and we already have pretty much everything. I mean, we don't have the pin, like the coordinates yet. So position is obviously gonna be like the center, and these are gonna be the half extents. Well, they're not gonna be, no. I mean, size is gonna be the absolute kind of width and height, but we're gonna use half extents from the middle. So it's gonna be like, how should we do this? Maybe I'll just write it out here for now. And yeah, so if it's a vec3 position as well, that kind of complicates things because we're not sure about its orientation in 3D space. But I'm just going to assume that this, because it's 2D, let's do this. So P0 will be position. We're basically probably just going to use the vec3's like coordinate. Let's do this. So GLM vec3, we're going to use the Z coordinate as is, and then to the X coordinate, we're going to do, like, for examples, minus size X times 0.5, and then same for the Y. So this is going to be Y and Y. So that's our bottom left corner, and then we're going to use whatever the Z coordinate is, like that. So let's duplicate this, 1, 2, 3. These are like our vertices. Okay, so we'll go kind of in a clockwise fashion. So this is plus plus, and then this becomes plus plus. So that way we're kind of bottom left, then bottom right, then top left is kind of the order here. And then we just need to draw a line from P0 to P1 with like the color, from P1 to P2, from P2 to P3, and from P3 to P0. Simple as that. And that's it, I think. That should be a lovely rectangle. So let's go ahead and try and draw a rectangle at the origin of our world. So we'll change this to draw rect. I mean, I guess we can do both just to make sure both work, because they should. Let's maybe not make this from the origin though. I'll make it from 2. And then we'll make draw rect from the origin with a size of 1. And we'll make it white. And we'll see if we see our beautiful rectangle. Yep, so that's off to the side, great. And then this obviously is a nice looking rectangle in the middle of our world. Now, before I forget, there's this thing called like, where do we do our initialization? I think it's like up here, yeah? There is this thing called like GL smooth line or whatever. I don't really use OpenGL that much these days. GL line smooth, like, okay, this is very, very bright, but so enable or disable server side GL, GL enable, and then line. If enabled, draw lines with correct filtering, otherwise draw alias lines, see line width. So, and then we have, there's a few different things that we can use. GL line, yeah, so depending on line, anti-aliasing is enabled. To enable or disable, call GL enable, and disable with argument line smooth. Line okay, yeah, so anti-aliasing is initially disabled, obviously. Yeah, so if we enable that, it should provide us with some kind of anti-aliasing. Again, I suspect this is very much driver and hardware dependent, but maybe this will look better. Sometimes in my experience, it kind of causes problems. So it kind of looks like there's now almost like a gap here, whereas I think there wasn't one before. Yeah, this looks a lot more solid to me in terms of actual line, but I guess I'll leave it on. And I think overall, especially when drawing individual lines, it looks better. Sometimes when drawing connecting lines, it's a bit weird. But again, you know, you could argue that for rectangles, you could make another vertex buffer or whatever. Like you don't really need another vertex buffer. Well, I guess you would. Well, you don't need to. You can keep track of offsets and stuff. But my point is you could maybe do a draw line loop, or like a draw line strip or something, and maybe that would look better or whatever. Again, I'm not going to bother too much. This is primarily for debug rendering. So how do we do the transform version? Well, the cool thing is, because this is a rectangle, we can actually just reuse our quad vertex positions because they're already perfect. And obviously we made them be like a unit quad, meaning it's a 1 by 1 meter quad. So because of that, we can easily just, let's grab like a for loop that goes through it. This is it, right? And then what we'll do is we will just basically do draw line, and this is going to be slightly annoying. I think maybe we should just make like the vertex positions up here line vertices 4. And then this will just be I equals the transform times S data quad vertex positions I. That goes away. And then that way we just have a little bit more control over this. So we do 0, 1, 1, 2. Again, you could also kind of put this into the for loop. Oops. 2, 3, 3, and 0. I'm just gonna leave it like this. I think this makes more sense. But yeah, if you wanted to, you know, again, as a YouTube person, I feel like I always have to explain everything. Otherwise, people are gonna be salty in the comments. But you could just basically set this to be I plus 1 mod 4, right? You don't even need this. You just do glm vec3 vertex equals that. There's my vertex, but you actually need the second one, so it's a little bit harder than this because you need to also have the second one already done. You can't just draw a line every vertex like this, but I'm sure you could figure something out. Like you could make another for loop, whatever. You can do whatever you want. There's a reason why I'm leaving it like this, and that's just because it just makes more sense to more people, I think. Okay, anyway, moving on. So draw rectangle with a transform. So now what we can do, again, to test this out, what I'm going to do is I'm going to go to like scene, and wherever we draw a sprite, we currently call draw sprite, let's replace that with a draw rect instead. And I'll make this, like, we'll take the transform as usual, and then we'll just make it be like a white, I guess, rectangle. And then we'll load our physics scene and make sure that that's all working. Again, it's not going to work in the runtime because we didn't override that, but you can see that with the physics 2D and everything, we get everything's rotated perfectly, everything works, and then if we hit play, we get our normal scene. But you can see that we kind of almost get like a wireframe-ish view of everything, and it looks good. Okay, so that is definitely working. That's pretty much it, I think. So we can render lines, we can render rectangles. The next step is going to be to kind of integrate this stuff with our existing like physics components so that we can easily visualize them. But then again, like, you know, we already have the ability to visualize circles because we already added that. So circles now, rectangles are done. Yeah, I think it looks pretty good in general, and we're probably ready to move on with like integrating the rest of the Box 2D stuff, because I don't think we actually have a circle collider yet. So that's going to be the next thing that we move on to. But thank you guys for watching this video. Please don't forget to hit the like button if you did enjoy it. Patreon.com/thechannel, best way to help support this series and get access to like the big Hazel's kind of code. I keep calling it like Big Hazel because this is what we're working on is Hazel 2D, of course. I'll leave your thoughts in the comment section below, and I will see you guys next time. Goodbye.